Here today with a pneumatically actuated control valve. For the industry that I'm about to go in and process, we use typically 3 to 15 psi signal for pneumatic to control our instruments. So this valve has is equipped with a diaphragm and a spring, and it can be attached to different types of valve bodies. So there's also two choices for this valve, to where you can see here the import for the air is right here, and there's also a port on top. The difference between these two ports is for fail open or fail close acting valves, to where if we lose our instrument air supply, the valve will stay open or stay closed based on this location and the valve setup. So coming into my regulator here, I have 120 psi signal or supply. I then reduce it down to a range that's usable for this valve. For this setup, this is called a bench set setup, which is a calibration setup. So I'm going to regulate it down. Our range for this operation is going to be 7 to 15. 7 psi signal relaying to this valve is going to be 0% action, output action. 15 psi is going to be 100% valve open action, output. So first thing we're going to do is turn it up and apply air, and this valve should not move until 7 psi. So once we take the load off of the valve, we're going to start the calibration on this. Once you take the load off the valve, when you hit about 7 psi, you have the load and you have some resistance against that spring. This spring is extremely powerful, and if you don't do this correctly, you could damage the equipment. So our first step is to remove this coupler, which actually connects the actuator stem to the valve plug stem. By removing these two bolts, you can actually grab and move up and down. I mean, it's a free-floating stem at that point. And then we're going to reduce the air pressure to where the actuator drops, and then we're going to bring it back up just to the point that it moves at about 7 psi. And then we're going to clamp this down, connecting with the coupler, connecting the valve stem and the actuator stem. This creates us our baseline, our zero set calibration. Since the valve is completely seated and we've connected it at 7 psi pressure, this gives us our baseline to where we can now start to calibrate the rest of our range. So from 0% open, we're going to now go to 100% signal, which is 15 psi. So we're going to crank it up, and you can see it as it goes through the range. It is proportional to the psi. For instance, on a 3 to 15 psi setup, 50% signal is going to be 9 psi. So right now we're at 15 psi, and as you can tell, it's dead set right at 100% open. This indicator is mostly for an operator's reference. During calibration, you can see here there's 2 screws. This can easily be tampered with, but once the valve is calibrated, it's a good indicator. So now that we're at 15 psi and we're at 100% open, this is obviously calibrated. But for instance, if this didn't have enough stroke and it wasn't 100% at our 15 psi signal, we would then have to make an adjustment to increase what's called the span. Something that's great about KPC and learning is, or our education is, not only, I'm going for a process operation, process technology degree. It's also required to take instrumentation level 1 and 2. So this makes us more well-rounded and ready for the industry, to where we know a little bit about the entire process, to where we can figure out, as an operator, when I go into the field, I'll be able to tell you, by knowing the diaphragm size and using the simple math formula, pi r squared, to find the surface area, with a 15 psi pressure exerting over that surface area, and having a valve distance of a 3/4 inch stroke, I can tell you the constant, and I can tell you what spring is inside this valve without even taking it apart. And that's kind of what separates us from other operators.